we are going to open the final block of the presentation, of 3 presentations, and we're going to start with the first one. We are going to go underwater. Quick show of hands. Please raise your hand if you've ever gone diving. Diving, anybody? Okay, nice. Nice, quite a few people. Okay, what about snorkeling at least? Have you ever done snorkeling? Perfect. So some of you, I would say roughly half of the audience, either went scuba diving or snorkeling. So we can see, or you have had the chance to see incredible beauty, which is underwater. And we'll be talking about scanning and mapping the underwater world. So, ladies and gentlemen, let's go and talk about how to drain the ocean and keep the data. Let me welcome on stage the CEO of Vectrino, Josip Rukavina. Please take us underwater. Give it up for him. Josip, enjoy the spotlight.
Thank you very much. Hello, everybody. It is hard to outshine first Ted's presentation that he had with everything, bridges, and then later we had a presentation, different presentations that are like stunning. There was a dog walking on, and now I had to outshine everything, but I will try. The name of the presentation is Drain the Ocean and Keep the Data, but the real name of the presentation would be Time Shift. This is something that Arash called me when we were talking 3 or 4 years, asked me, is the time shift the word you are trying to find? Yes, the time shift, and I will try to explain you how we drain the water and how we make time shift inspections. But first of all, I will just share a little bit about Vectrino. Vectrino is a company that was founded 12 years ago by 2 brave people. My wife and I one day decided to leave corporate business, and then we started Vectrino. The first idea about Vectrino was to be special, but we didn't know what we are going to provide and what are going to be our services. But we found out soon that nobody is doing underwater inspection. Nobody. And we thought to ourselves, okay, is there equipment to buy for underwater inspection? And then we found out after 1 or 2 years trying to go around the world trying to buy equipment that all producers of underwater equipment are lying and not producing the equipment that we need. They were briefly showing us slow and small-scale presentations of the 3D space, but it wasn't enough for us, especially as we wanted to make time shift inspection in the future. And then COVID struck, you know, and we had a lot of time, and then we decided it would be wise to develop our own equipment for the underwater inspections. We didn't thought that it is going to be so hard. Found out that it is going to be hard, but we also had lucky, because sometimes stupid people are lucky. And we found solution. Especially we found solution for banana effect. Whoever did photogrammetry ever in air know what is banana. It is curvature of the everything. So you use GCPs to make everything flat, and you can imagine how complex it can be in underwater, where you have 2 medias, air and the water, and you don't have any GCPs. Okay. At this moment, we provide to our clients unique technology for draining the water, especially in some areas. We are not the company that is doing oil and gas, deep water, and we are not the company that is doing the inspection that is deeper than 50 meters. And the reason why is because nobody is doing the inspection from 0 to minus 50 meters. And then we found out there is a necessity for such a job, and then we are going to make it. And how do we do it? We have a few guys that are working 7 days a week, 24 hours, 365 degrees, going around the world with some 15 or 20 meter carbon pole and some cameras. And somebody a few hours ago mentioned that, are you those guys with the GoPros? Yes, we are those guys with the GoPros, because we truly believe that understanding of the light and wavelength is more important than the type of the camera. We can do it with a full frame camera, with any kind of camera, but we would like to have it on a KISS principle. Keep it, you know, stupid, simple, stupid, whatever. So we have guys that are just racing down the road, and by that way, they can do 600 meters in one day, 10 meters deep, so 6,000 square meters, which is enough. Especially if you ever collect data, then 6,000 meters per day per one technician is really a lot. So at this moment, we are doing the service around Mediterranean. We can work only on 40% of the world seas because we work only in clear water to medium turbidity. If the turbidity is high, we are not the answer for that person. Surely not the answer. But if the medium turbidity and clear water, and which is maybe whole Mediterranean and Caribbean and all beautiful places, we are down there working. And we have 3 teams that are constantly working, bringing the data to the company so we can better understand the procedure. If we can better understand procedure, then we can be quicker. If we are quicker, then we can make it, we can sell it better. Okay, the thing that I mentioned already, we can do 6,000 square meters per day, and this is important. The guy who is collecting the data doesn't need to know anything. He just needs to place the rod down to 50 meters and then bring it up. Everything the rest is done by electronics or our software that is later doing the calibration on it. Okay, where we can apply our technology. Breakwaters up to 50 meters deep, blocky walls, ski walls, sheet pile walls, 30 meters deep, and we can work again in clear water to medium turbidity. Accuracy at this moment, there is a lot of talk about accuracy. I will show you later what we mean with the accuracy. We can achieve 2 centimeters in 500 meters surely. So we can overlap data in the future. Okay, what is time shift and why do we do it? We like to come to the location, make the inspection, and when something is changed, we go and do it again. This is especially interesting for owners of the asset, which are port terminal operators or port authorities, because with the time shift inspections, you can teach computer how to say what is the time of the break point. So if you have 3 or 4 repeatable inspections, you can probably understand when the collapse is going to happen. And for who is this important? For, let me say, insurance, who insures the terminal where the big ships are docking. They don't like to sell insurance to their clients if they don't know the real data behind it. Okay, how does it look? There is inspection in 2023. In 2024, if you're just looking at the plain mesh, you won't see the difference. But if you go a little bit closer, you can see what is happening with the concrete. And especially in underwater, with the concrete, you have to understand concrete is a life form. It lives, you pour it, and then it lives for 100 years. It has its own way. It is attacked by chemicals, it is attacked by the biological stuff, and it, in its own way, it should be so much stronger through the time, but because of different mechanical, chemical, and biological procedures, it got destroyed. And it is important to know what is the time shift, between time shift, what is the time when the collapse will happen. Okay, how do we do it? We do it by monitoring few parameters which are not easily understandable in photogrammetric way. So we do the turbidity monitoring, we do the salinity monitoring, we know how our domes are making deformation, because we are specially casting the domes. And also, we know what is happening with wavelength when it's coming from the air, then to the water, and from the water, then again to the air and to the lenses. So you can see the model, the real model that was built up, drained the water, and then later water was built up in Unreal. I'm not sure in which engine. I think this was done in Unreal. Okay, and how accurate are we? And for the most people here, and I don't know if anybody of you heard about these norms, but if you're doing any kind of measurement, anywhere. You should read these 3 norms because they are rules of accuracy, uncertainty, and how to make everything that you can make repeatable. Okay, and based on everything that we are doing now, then time shift and everything, we are also developing AI model that we don't like to share at this moment, because our AI model is now on 35 million photos, and MIP is around 96.9, so we are not still at 97%. I think when we are going to be at 200 million photos, that we are going to be above 99%. So it is long, long procedure, and you have to know, for understanding what is happening in underwater, for making AI on the cracks or something that is moving, you need to greatly understand is concrete or some steel attacked by different, is attacked by chemical procedure or biological, like some shelves or something drilling inside the core of the. So I think in maybe 3 or 4 years we will be on 200 million photos, and then we can share the AI model based on that. Okay, but the most important thing, what differentiates us from other companies, is our portfolio. In a lot of cases, when every time you reach some areas and you talk with somebody and you want to buy equipment or you want to buy service, they will always say that their showcases are under NDA. Yes, a lot of things are under NDA, but a lot of things are not under NDA. So all that we are working, we can showcase and present to our future client, because our portfolio at this moment is really, really strong. So you can see there is Unreal Engine, there is Multibeam, laser scanning, underwater scanning. So you can see Multibeam. There you can see the curvature, the banana effect that is occurring down there in this area. We specially left it for you, so you can comment. But also, as we can drain the water, we can put the water back, so it can become real digital twin with the data, with the tides going up or down. And also we can move out the overgrowth by removing the textures, which is for inspecting the big and long underwater walls. Really, really interesting. And then we came to the next video. You can see it. This is from NIRA. Arash will show you later how the NIRA is working. But you can see we did an inspection of photogrammetry wall, and in one moment we will overlap with the multi-beam data. So at one moment you will see, at this moment you can see that on the right side there is multi-beam and the left side is photogrammetry. And we are overlapping to the accuracy that is needed for the client. But you can see the ultrasound doesn't give you such information for big understanding of what is happening with the cracks. But if the high turbidity, you don't have the solution. The multi-beam at that point is the only solution. Okay, and there is a new project in Dubrovnik. If you visit Croatia, our home country, you surely came, if you came with a cruise ship, you surely dock at this area here. But you can see it in underwater how it is really looking and what rehabilitation needed to be done. Okay, and the latest project done in our home city, we scanned the wall after the works, so the client really understand what he paid for, because if he sees just the video or diver information, then he doesn't understand what is happening. And here there is 300 meters wall, really, really long, and without any curvature or banana effect, as it is called. Okay, hopefully I just come to give you a little bit information that is possible to make underwater inspections, that it's possible to make underwater models, and remember, no questions, Jure.
Josip. That was a very cheeky remark.
No, be careful.
I will disappoint you. We have some
Okay,
questions.
okay.
Like, great job, guys. You keep on sending them. Wonderful. I love this. So let's take a look at the first one from Martin. So how do you deal with the fact that the water surface reflects light? How do you scan near the water surface?
Near the water.
Yeah.
we have this tide meter, and then we are always looking. There are ports that are better, and there are ports that are not so good. If you have only 40 centimeters in tide, then it's hard to scan it. And especially in sunny areas, because if you ever did a photogrammetry underwater, you know that the killer is more sun than the rest, because the sun will give you the zebra stripes, and zebra stripes won't help you make the 3D model. But we managed to do it. But this is the hardest thing to make the inspection.
Josip, can you talk about money? Can you talk about the cost? What is the cost for software and hardware?
We are offering service in Mediterranean, but mostly we are giving the companies opportunity for the states to take the license, to become our licensee, and then work with our equipment, and we will do the post-processing later. So the prices are, when you're unique and alone on the market, apparently, then the price is something that we negotiate with our future licensee.
Biden is giving you actually a shout out. Thank you for talking about the standards regarding the methodology to assure the quality of the data. Do you follow any standards related to the photogrammetry?
We like to measure everything. But when you're measuring, you should go always to the ISO standards, and you always measure lengths. If length is the SI system, the first, so we know what is, and we always come back to the length. So 1 meter is always something we want to find ourselves.
Cool. Does it require permissions to scan near ports? Is it on your side or the customers?
Okay, for the permission, we are now challenging in EU. We are challenging new stuff, because data security is now going. You know that everybody's trying to say, and now you have people who are how to say, not in the subject, and they think that everything that they own is under some kind of security check under it. So we now have challenged last 6 months with the data, because everybody say, okay, this cannot be publicly shown, but it is only wall, you know, and you understand me. It is not so important, but the challenges are here.
A couple of questions that actually touch on the topic of water clarity.
2 questions.
Okay. So, the last one, all right?
Okay.
So, because a few of you actually asked this question in different words. So, how do you deal with water clarity or movements affecting the scan quality?
This means our movement or the movement of...
I think the movement of the water and then the water clarity.
It depends. It depends what type of turbidity you have. Sometimes you have big particles floating around you, and then have small particles. Then you have something that is more to the turbidity level, and it is challenging to the level that every project is special. You have to prepare for every project. But the major thing is that we take the lights, if we need to have artificial light, out of the picture by making the light go to direction of itself. So we never do the shadows for ourselves.
Perfect. Josip, that was the last question.
Thank you very much.
I promised. Let's give it up for Josip one more time. Great.